stocks. And the increased use of those group 2 and group 3 base stocks leads to the reduction in lubricant solvency, which is necessary to solubilize those sludge and deposit precursors. Yeah, there has been a couple of reports published regarding the correlation between the base stock chemistry and the oxidation behavior of the lubricant. However, there are very little research has done related to the correlation between the deposit control performance of lubricant and the base stock chemistry. And the blend of the different type of base stocks has not been fully explored. As we mentioned before, we have seen the evolution of the base stock, especially in China, moving from group 1 to group 2 and group 3. So we want to understand where those different AO systems perform the best, especially to meet a target such as RTVOT 800 minutes. So we conduct a mixture of base stock studies, which show different type of base stock from group 1, group 2, and group 3. And based on observations and the report they have reported earlier, we know like the aminic system containing PANA gave very good RTVOT response. However, they have very poor CMA sludge performance. And secondly, hidden phenolics have very good performance in terms of sludge control. And the BTBT has the best performing antioxidants to balance those oxidation and the deposit control. So with that in mind, we designed an experiment and used 3 different AO systems. One of them is PANA, OBDPA, and BHT. The other is PANA, OBDPA, and DTBT. And the third one is just like a whole aminic PANA plus OBDP. OBDPA. Okay, with all the results we present so far, there are a couple of interesting observations. The first is like the PANA